Hey there. This will be a short presentation describing the functioning of the atmospheric system and how external forces can change the existing energy balance. This is part of our core theme 3, Patterns in Environmental Quality and Sustainability. The objectives are to be able to first describe the functioning of the atmospheric system in terms of energy balance, and second, explain the changes to the balance due to external forces. Our atmosphere is considered an open system, meaning it receives inputs from both the sun and the earth. The energy from the sun comes in the form of shortwave radiation or insolation. Of course you know this insolation is vital for life on Earth. As you can see, not all of the shortwave radiation passes through the atmosphere. A small portion of the shortwave radiation is reflected by our atmosphere back into space, as seen here. The rest of the insolation, here, is able to pass through the Earth's atmosphere to the Earth's surface. This is the first part of the equation. A small part of the shortwave insolation will be reflected directly back outwards. This is known as albedo, and we will discuss this process a little later in the presentation. Most of the incoming shortwave radiation will be absorbed by the Earth and then re-radiated as long-wave radiation. Very hot bodies emit shortwave radiation while cooler bodies emit long-wave radiation. Much of this long-wave radiation is absorbed by the atmosphere, later be passed on to space. A very important part of this energy, though, is directed back to the Earth. In essence, the atmospheric gases help to maintain a balance of energy on Earth. The part of the balance we are describing is known as the greenhouse effect. It's what keeps us from having a situation like you see on the Moon. The Moon is an airless planet that is the same distance from the Sun as the Earth, which means it would receive just about the same amount of incoming shortwave radiation. However, due to the lack of atmospheric gases like CO2, daytime temperatures on the Moon may reach around 210 degrees Fahrenheit and then fall to about negative 240, 250 degrees Fahrenheit at night. Think of a parked car on a hot summer day. Incoming shortwave radiation passes through the car window and is either reflected back out, as if you were to use one of those like window reflectors, or it is absorbed by the interior of the car and then emitted back as long-wave radiation. This long-wave radiation can't pass back through the windows, and this thus heats the interior of the car. Our energy balance is a budget between the inputs and the outputs. Inputs include the shortwave radiation from the sun, known as insolation, and also the long-wave radiation that's reflected back into our atmosphere. The outputs are the shortwave radiation reflected back by the Earth's surface, known as albedo, and also the long-wave radiation that is absorbed by the atmosphere and later let back into space. It's a simple system. The energy is balanced between incoming and outgoing, but with a special function of keeping the Earth at a hospitable temperature range in the process. But what happens when something upsets the balance of energy? And think about what types of things might change the inputs or the outputs that we listed before. What if we change the amount of shortwave radiation, from the sun? What if we increased our insolation? Maybe due to sunspots or the angle the insolation strikes the Earth. What if we change the amount of shortwave radiation reflected back by the Earth's albedo? So either increasing or decreasing the albedo rate of the Earth. We have external forces causing changes to the balance. These can be variations in solar radiation, such as sunspots, changes in latitudes or tilting of the Earth. We also have variations in the albedo of the Earth's surface. In discussing the variations in insolation, we first can observe that variations in energy emitted by the sun. These variations can occur due to sunspots. There is recent evidence to show that 11-year cycles of sunspots correspond with increasing global temperatures. Another contributing factor to the amount of energy received from the sun would have to do with the distance from the sun to the surface of the earth or the earth's atmosphere. Areas that are close to the equator receive more heat than areas that are close to the poles. This is due to two reasons. Incoming solar radiation is concentrated near the equator, but is more dispersed near the poles. Insolation near the poles has to pass through a greater amount of atmosphere, and thus has a higher chance of being reflected back into space. The last external factor that may influence our energy budget is the albedo of the Earth. Various materials found on Earth will have a different reflective property. Remember the parked car example from earlier. By using a reflective shield in your windshield, you've created a barrier to the short-wave radiation that has a high albedo that will reflect the short-wave energy back out of the window before it's been absorbed by the interior. Here you can see a list from greater to less albedos that would be found here on Earth. Different parts of the Earth have different levels of albedo. Different scenarios would decrease or increase the short-wave radiation that's reflected, replacing grasslands with deserts, increasing sea levels, increasing snow cover, increasing or decreasing cloud cover can each have an effect on the amount of short-wave radiation that's reflected back into space and thus not absorbed by the Earth. Thus, with changes to the composition of the Earth's surface, we may change the reflective properties and thus alter the balance. At this point, you should be able to describe and illustrate the Earth's atmospheric system in terms of the energy balance between short and long-wave radiation. Also, you should be able to identify and explain changes to the energy balance due to external forces. For example, changes to solar radiation and changes to the albedo of the Earth. Thank you. Thanks so much. The end.